Hey everyone, it's Bradley Bush with an algebra video. Today we're talking about solving exponential and logarithmic equations, but specifically we're going to talk about a trick called the LogTrick and how we can use that to solve exponential equations. So let's discuss briefly what's going to happen today. Our to-do list, we've got two things on our to-do list, so it's not going to take us that long, so it'll be great. The first thing is, let's talk about the take log trick and what it is and how it helps us, and then we'll have two examples. So let's get started. The log trick is sometimes when you have a variable in an exponential equation, and that variable is in the exponent, and you want to solve for that variable. That's the purpose of the equation, to solve the equation, and for x, for example, and x is in the exponent, then taking the log of both sides of the equation often does the trick for you. It often allows that exponent to come down in front, and then you can solve for the x that you need. So a great trick for your bag of tools, your bag of tricks for solving exponential equations specifically, is to take the log of both sides of the equation. So let's talk about an example. Let's show you an example here. So here's our first example. The problem we're trying to solve is 5 raised to the x equals 134. The x currently is in the exponent, and we can't do anything with it. We can't solve for it as it is. We've got to get it out of the exponent. And a great way to get our variables out of the exponent is to use a log. So if we take the log of both sides of the equation, then that exponent comes out front, and we can easily solve for the variable x. So that's what we're going to do. We'll have our equation 5 to the x equals 134. And I'm going to take the natural log of both sides of the equation. Doesn't matter if you take the natural log, or if you take the common log, or log, any base of a log, as long as you're consistent on both the left and right side. I just like the natural log because it's one less letter to write out, ln versus log. So once we take the natural log of both sides of the equation, then again, our log rules let us take this x out in front. And so now we have x times the natural log of 5 equals the natural log of 134. And we're almost done, actually. Now all we do is, let's divide by the ln of 5. Whoops, I don't need an equal sign there. We can see that the natural logs cancel, and we have our solution. X equals the natural log of 134 over the natural log of 5. So that was actually pretty slick, right? Not too bad at all. And very, very effective trick to take the natural log of both sides if the variable you want to solve for is in the exponent. So let's try another one of these problems that's very similar. Here's another problem here. The equation that they give you to solve is in yellow, the yellow box here. 5 raised to the quantity x minus 2 equals 4 raised to the quantity 2x plus 3. So again, the x is what we want to solve for. It's in the exponent. One of the best ways to get stuff out of exponents is to use logs. So we're going to again take the log of both sides of the equation. So we have 5 raised to the x minus 2 equals 4 raised to the 2x plus 3. And I'm going to take the natural log of both sides. So the natural log of the left and the natural log of the right. This is wonderful, right? Because it lets us take the exponent out front. Both exponents out front on the left and right side of the equation. So now we have x minus 2 quantity multiplied by the natural log of 5 equals quantity 2x plus 3 multiplied by the natural log of 4. Next step, we want to distribute that natural log of 5 through the left side and distribute the natural log of 4 through the right side. So that gives us x times the natural log of 5 minus 2 times the natural log of 5. And on the right side, we get 2 times the natural log of 4 plus 3 times the natural log of 4. So our next step now is we want to isolate the terms that have x's in them, which is the x times ln of 5 on the left. Oh, and I forgot to write the x on the right, so let me add that. I'll put it in red just so you know that I just added it late. So 2 times x times the ln of 4 on the right. So if I want to get all of the terms highlighted in blue to the right and everything else to the left, then that means this term 2x times ln of 4 is going over to the left side of the equation, so it will become negative. And that means the negative 2 times ln of 5 on the right will come to the left and become positive. So let's make those switches. We've got x times the ln of 5 that is already on the left. It'll stay there. And we'll have the negative 2 x times ln of 4 that came from the right side and became negative. Then we'll have equals, and we will have the 3 times ln of 4 that was already on the right. And then the negative 2 ln of 5 will come to the right side and it'll change to be positive. Perfect. Now we also notice that each of these terms on the left, after our algebra, each term on the left has an x. So we can factor that x out as a common term. And what we're left with is ln of 5 minus 2 ln of 4. And then the right side stays the same. So I'll just copy it down. Last step is we will want to divide away the stuff that we don't want to have on there. So I just copied and pasted that line, and now we have the ln of 5 minus 2 ln of 4. We will divide both sides by the same thing. Ln of 5 minus 2 ln of 4. We can see on the left-hand side they cancel out. Perfect. And we have our x isolated, which is what we wanted. We wanted to solve for x. 3 ln of 4 plus 2 ln of 5, all divided by ln of 5 minus 2 ln of 4. And we're done. That's it. So, maybe I should note that the answer, 3 ln of 4 plus 2 ln of 5, quantity all divided by ln of 5 minus 2 ln of 4 is approximately negative 6.34 if you put it into a calculator. And also our last example, I should probably tell you what that is. This is about ln of 134 over ln of 5 is about 3.04. And if you wanted to know how to put this into a calculator, let's put this quickly. into a calculator so you can see what it looks like. Let's clear our screen. What do we have here? So we want to put parentheses around the top and the bottom so we know, because there's a lot of terms here and they're added and subtracted together, and if we don't have our parentheses in the right place, we could have some issues with what our calculator thinks we're giving it and what we think we're giving it. So 3 times ln of 4 plus 2 ln of 5 close parentheses. So now we have the entire numerator in parentheses divided by open parenthesis, and we're starting at the bottom now. ln of 5 close parenthesis minus 2 times the ln of 4 close parenthesis, and then another close parenthesis to finish off the parenthesis from the denominator. And then we hit enter, and we have voila. We have negative 6.34, which is, I truncated it, which is approximately what we had right here. So there you go. If you guys have any questions, let me know. Thanks for watching.